everybody. Today we're going to take a look at light again, and we're going to think about the wavelength and the frequency and maybe even the energy of photons of light. In our last lesson, we thought about the different types of light, and we even introduced these concepts of the speed of light, which is given the letter c, and its number, which is always 3 times 10 to the 8th meters per second. We considered wavelength, which is given the symbol lambda and has units of meters or meters per cycle. And we also thought about frequency, which is given the symbol called nu, and it has units of cycles per second or hertz. And the very last thing was we thought a little bit about this equation, C equals lambda times nu. And that's an interesting equation because it tells us a lot about photons of light. For example, it shows us that frequency and wavelength are inversely proportional, which makes sense. If we have a long wavelength of light, it's a big number, but the frequency is going to be very low, a small number. So let's do some calculations using C equals lambda times nu. What is the frequency of radiation with a wavelength of 500 meters? Well, what is the frequency? That is what we want to calculate. So we want to know that number right up here. We know what the wavelength is, that's 500 meters, right down here. And we know that C is always 3 times 10 to the 8th. So the first thing that we need to do is rearrange this equation to solve for nu. So we write down C equals, I wish it didn't, I don't know why this pen is doing that, I'm sorry folks. C equals lambda times nu. Rearrange to solve for nu. That means we have to get rid of lambda from the right side of the equation. So lambda cancels with lambda and we're left with nu equals C over lambda. I'm going to rewrite the equation from left to right. So let's just plug in C. Every time it's 3 times 10⁸ meters per second. And lambda is 500 meters. So let's go ahead and calculate this. 3 exponent 8 divided by 500 equals 600,000, or 6 times 10 to the 3/5. 6 times 10 to the 5th. We need to have units for this. Let's take a look at what we have here. We have 500 meters per cycle, and we have 3 times 10 to the 8th meters per second. So meters will cancel with meters, and we're left with cycles and seconds. So cycles is on the bottom of the bottom, which can be flipped over to make it on the top of the top. So that leaves us with cycles per second. Let's take a look at the next problem. What is the wavelength of radiation with a nu, a frequency of 6 million cycles per second? We have lambda and we have nu, and we know our equation up here is C equals lambda times nu. And so we have to solve for lambda this time. So we'll use approximately the same procedure. We want to solve for lambda, so we want to get lambda by itself, wavelength by itself. That means we have to divide, we have to get rid of nu. So let's put nu down here and divide it. Do the same thing to both sides of the equation. Nu will cancel on the right, and that leaves us with lambda equals C over nu. And usually we want to rewrite this equation from left to right. 3 times 10 to the 8th divided by 6 times 10 to the 6th equals 50. So our wavelength should be 50 meters. Let's just figure out why it is 50 meters. Well, we have meters on the top of the top, and then seconds here, and seconds on the bottom of the bottom as well, so they'll cancel. And we're left with meters per cycle. Today we worked with this equation, C equals lambda times nu. I just want to show you what the next topic is going to be. The next thing that we'll be doing is we'll be taking a look at the energy of waves, and we're going to give that the symbol of E. And to calculate the energy of a wave of light, we're going to use this equation, which also involves nu, which you're familiar with. That's the frequency, cycles per second or hertz, and then a unit which is called Planck's constant, which is given the letter H, and H is always this number on the right, 6.63 times 10 to the negative 34th joules per hertz. So we're going to plug that in here, and if we know the frequency, we'll be able to just multiply those and get the energy. So energy is going to be in units of joules of energy. But that's just something to think about. Today our topic was C equals lambda times nu, where C is the speed of light, lambda is wavelength, and nu is frequency.